Howdy. We'll be talking about 8's on pylons. If you like aerial photography or if you like shooting guns, then this is the maneuver for you. This is a commercial maneuver, so you will be doing this on your commercial check ride, so you'll have to know this one. This maneuver started back in World War II. And basically what it did is it allowed an airplane to fly in a figure 8 around 2 points, 2 positions you could call pylons, right? And what this did was it allowed the door gunner on the side to have a constant sight picture on its target, so he wouldn't have to move all the way around trying to find his target. He could just aim at one spot and he would have it. So you can see how this would be really beneficial for aerial photography as well, right? You just aim at one spot and click, no matter which position you are in around it, right? This maneuver is similar to turns around a point, a private pilot maneuver, but the main difference here is that it is not equidistant, and then there are 2 points. Those points are called pylons, right? Instead of just a circle, you are doing a figure 8. So how do we fly around a point without keeping it equidistant, but maintaining the same sight picture? We use a thing called pivotal altitude. Let me write that down. Okay. Pivotal altitude. Okay, so what is pivotal altitude? Pivotal altitude is a specific altitude at which, when the airplane turns at a given airspeed, the plane will appear to pivot around the pylon. Basically, when you're turning, the pylon won't move around on you. It'll be, if you look out your window, it'll be on that same spot on your wingtip throughout the entire turn. Okay, so how do we determine pivotal altitude? Well, we use a simple formula. That formula is ground speed squared divided by 11.3. Okay, so let's look at that for a second. Let's take, let's say we're using 100, we're at 100 knots ground speed. So we look at our calculator out. We will do 100 times 100, it's 100 squared. 100 times 100, and that equals 10,000. Okay, then we will divide that by 11.3, and we will get 884.9, or just if you want to round up, you get 885. Okay, so that is our pivotal altitude. That's how you find your pivotal altitude. Now, something that you'll need to do is, in a practical sense when you're actually flying, is you need to take that and then add in your field elevation. So if you're flying around at near Addison Airport, the field elevation there is 645 feet. So you will take this 885 and add 645 to that, so it's plus 645, and you will get 1,530 feet. And this is your new pivotal altitude that you will be flying at. This is whenever you look at your altimeter in the air, this is your pivotal altitude, okay, at 100 knots. One thing that can help you is to have a chart printed out or written down of different ground speeds and each one's related pivotal altitude. This will help you because when you're flying around, all you have to do is look down at your knee board and you can see what the pivotal altitude is for the ground speed that you're at, right? You don't have to go through and do a whole bunch of calculations while you're flying. Okay, so it makes it quite a bit easier. So how do we perform this? Well, first we're going to start with, as always, we're going to start with our checklist. Always perform your checklist. It's your pre-maneuver checklist. Okay, you're going to look for a place to land. right? Just in case of an emergency. Remember, this is a ground reference maneuver, so we are flying close to the ground. Okay, so we definitely want to be looking for a place to land just in case of an emergency. You know, always looking out. Okay, and then we're going to do our clearing turns. While we're doing our clearing turns, we can also still be looking for a place to land. This also allows us to check for our wind direction, see which direction the wind is actually coming from. And we're able to look for our couple pylons that we need. Right? And our pylons need to be within a half mile of each other, give or take. Right? You're obviously not going to make them, it's not going to be as accurate as possible. But you want them pretty close, but you don't want them too close, and you don't want them too far away, or it's going to throw your whole maneuver off, right? Then you want to make your radio call. Let other pilots in the area know that where you are, roughly where you are, what altitude you're at, and basically what you're going to be doing. So you're going to be doing 8's on pylons, okay? You will be performing this at maneuvering speed, which is VA, so whatever that may be for your aircraft. Okay. Now, whenever we start this maneuver, we're going to start this just as we would in a traffic pattern. So let's say we have our 2 points, and let's say the wind is coming from this direction. It's going north, right? We're going to enter at a 45 degree to the downwind, 45 degree angle to the downwind. So if the wind's coming from here, we would be starting over here, roughly about 45 degrees. And then once we are wings level and a beam that first pylon to our left, that is when we will be starting the maneuver. So once you are abeam the pylon, then you will start your figure 8 around both pylons, and then you will exit on your entry heading. So it is a good practice whenever you start the maneuver to bug your entry heading. Okay, so that you know what heading you need to come out on. Okay, now when you're going through this, you're going to be making altitude adjustments constantly because of the various wind changes. Your pivotal altitude is going to change throughout the maneuver. So when it's going this direction, just for example, okay, so if you are flying in this direction, you are being pushed from behind, so you have a tailwind. So let's say you're flying 100 knots, okay? And you have a 20 knot tailwind, okay? So you'll be flying actually at 120 knots if you are going directly with it. Okay, so something to think about is what is the wind going to do to us during different points of this. So if we're right around in here, this is when our ground speed is going to be the greatest. So our ground speed, because we're going, you know, with the wind, we're being pushed by the wind, so our ground speed is high. And so our pivotal altitude will be high. Now let's explain that real quick. Let's talk about that. If you are above your pivotal altitude, so we had that 1530 earlier. If you are above that, the wing will move behind your point. Okay, so the point will be ahead of you, which means you are too slow and you need to pitch down to catch up and grab it again, right? If you are below your pivotal altitude, you're below 1530, okay, the wing will move in front of your point, which means the point will be behind you, So you're going too fast, and you have to pitch up and climb back up to your pivotal altitude. Okay, so it's depending on your altitude. If you get above or below, if you're too fast or too slow, you're gonna have to pitch up or pitch down in order to maintain that. And that is how we keep the same sight picture the entire way through. So at this point right here, our ground speed is high, so our pivotal altitude would be high. We'd have a high pivotal altitude over here. Now, if we're down here, we're going against the wind, right? So what happens when we go against the wind? We're slowed down. So our ground speed will be slower, which means our pivotal altitude will be lower, okay? And then the same thing happens over here. Ground speed is high, we're being pushed, which means our pivotal altitude will be high. When we come back down, we're going against the wind, so we're slower. Oops. Our ground speed will be low, which means our pivotal altitude will be low. Okay, does that make sense so far? All right. One way that you can look at this to tell if you are on your pivotal altitude is by looking outside. Now, obviously, this is a visual reference maneuver, so you need to be looking outside most of the time, only glancing in at your instruments every here and there, every now and again, just to make sure that the instruments are saying what they're supposed to be saying, right? Other than that, you're looking outside. But if you look outside, let's say this is your point right here. And now, if you are too low and you look down at your point, this is what it's going to look like. The point will be behind you. If you look down and you're too high, the point will be in front of you. If you are right on your pivotal altitude and you look down, your wingtip or whatever point you had will be directly on that pylon, and that is what you want to have. You want to have right in here the entire time. When you look down, you want to have that point directly on your wingtip the entire time, okay? So you'll base that based off of your ground speed and what it looks like on your wingtip. So you might have to go up and down depending on where you're at in the maneuver. Some issues that may come up is not making any clearing turns. I did this a lot during my training. I just wanted to get right into the maneuver, so I said screw it to the clearing turns. This is a no-no. You always want to make sure you're doing clearing turns for safety and everything else like that, okay? Having a bad entry, say you're not entering on a downwind, you're not entering on the 45, this is going to throw you off because if you enter at some random point, right, it's going to take you a lot longer to try and figure out what the winds are doing to you. Whereas if you enter from the 45 degree to the downwind from the beginning, you already know where the winds are and what's going to happen at each different point in this maneuver. Okay. Being uncoordinated. A lot of people will try to use their rudder to keep their wingtip on the pylon. This is a no-no. You don't want to use your rudder. You want to maintain coordination the entire time. Your rudder should only be used for coordination. Okay? Not looking for a place to land. Remember, this is a ground reference maneuver. We need to have a landing spot picked out because we are so low. If you don't have one and something happens, you don't have a whole lot of time to figure out where to land. Okay. Having bad pylons can get you in a lot of trouble, because if they're too far apart, or if they're too close, or if they are just unrecognizable once you get to a certain point. Say you pick a tree near a whole bunch of other trees, it's going to be pretty easy to confuse that tree with a different one. Same with a pond. Okay, so it's probably preferable to do this around intersections, maybe like a couple water towers, stuff like that, stuff that's going to stand out. Okay. In this maneuver as well, according to the PTS, we do not want to exceed 40 degree bank. So we shouldn't be over banking in this maneuver. Okay, we should have a nice steady bank the entire time. We shouldn't be trying to, oh, I messed up, I got off my pivotal altitude, so I'm going to bank more to try and recover our point. That's not how this works. We're using our pivotal altitude to recover our point, not our rudder, and not banking more. Okay. So these are all things to look out for, and that is how you fly an 8's pylon. So if you're ever looking into get into aerial photography, you know exactly what to do. You know exactly what to look out for. I don't see anybody going around being a door gunner these days, but aerial photography is going to be a great one for this maneuver. Enjoy.